For child speech therapy to be most effective, it needs to be frequent and high intensity. To reach the appropriate treatment dosage, children will often practice at home, where their caregivers lead the sessions and provide feedback. However, caregivers are often inexperienced and uncertain when it comes to critiquing child pronunciation, which means they can be lenient and unreliable evaluators. One alternative to having caregivers provide the pronunciation feedback is to use automatic mispronunciation detection algorithms, which can be added to digital speech therapy applications. We previously found that mispronunciation detection dramatically outperformed caregivers at identifying word-level mispronunciations in a field test. In this work, we investigated phoneme-level error detection by training phoneme-specific classifiers to identify mispronunciations using posterior probability-based features. This technique was proposed in the L2 pronunciation training literature, but had not yet been applied to child speech therapy. We implemented two types of phoneme-level classifiers, one with a logistic regression classifier and one using support vector machines. We used a custom corpus of disordered speech from children recorded during home-based speech therapy practice in the Sydney, Australia region. We also gathered a set of expert annotations for this corpus. We forced aligned the child utterances and passed them through an acoustic model to generate posterior probabilities for each phoneme class. The log posterior probabilities and log posterior ratios were then used to build the final feature vectors. We ran two tests, one using our full corpus to compare our mispronunciation detection classifiers against a goodness of pronunciation baseline, and one using a subset of the corpus with ratings from student speech-language pathologists so that we could compare the classifiers against humans. In these tests, we used the top 8 phonemes according to the number of correctly and incorrectly pronounced samples. We found that the phoneme-specific classifiers outperformed the baseline goodness of pronunciation scoring. The logistic regression classifier was better by 11.1%, and the support vector machine was better by 10.4% relative to baseline. We didn't find any significant difference between the two types of classifiers, though. Even more importantly, our classifiers also outperformed the student clinicians. The logistic regression classifier did 18% better, and the support vector machine did 16% better than the students at identifying correct and incorrect pronunciations. Based on our results, we believe that child speech therapy application designers could use these methods to provide automatic feedback in their systems. Significantly, this can lighten the load on caregivers by letting them lightly supervise and support instead of directly managing home practice as an evaluator, which could increase the quality and quantity of home-based speech therapy practice for children. Thank you for listening.